95% of all parents are not ready to be parents when they become parents. That's real, and it's honest. There's
all right, guys.
When I was like, Jesus, we're going to have a conversation real quick. And even now, it's like...
Just in case any of you are in the Why the Hell is It 12 camp.
Those moments when you're like...
Does this look familiar?
Yeah.
It's the variance, right? It's not proven. That's why.
Genius from another issue.
So if you've never had calculus, you have
Go ahead.
it.
But it's like...
But there is a reason for it. LCD between these would be... Well,
Don't knock it. Don't knock it, TJ.
huh?
Is this going to be the next chapter?
Oh, hell no. No, no, no. 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 I'm not going to teach you calculus. That this symbol here, that long skinny S, it's the integral, and there's a whole first part of the semester. Calc 1 is building up to that. In Calc 2? In Calc 2. You learn it in Calc 1.
And you go to Calc 3 and you must do 2 or 3 of these.
Yeah. Yeah. Triple integration where you got to change the limits. Hello. Oh shit. All right, guys. I should probably put that away. So, guys, everybody, we got to focus because we got to get through this stuff here. So we're about to get into the chapter where we can finally test claims that are made, right? Or test. So, for example, I've got the internet up here. You do my favorite thing to do for statistics, write the word study. Look at the past week or so. Oh, here we go. Just got on to the study.
What did it say about caffeine?
Hold on. That's awesome. We have a link to the study. You guys suck so bad. The first link should be to the study itself, and it isn't.
Quick question.
Yes.
Chris, are we going to need to know the formulas by heart, or are you going to provide them for the quiz?
What I do in the last quiz.
Provided them? Provided them. I don't.
When is the quiz? Monday?
You can kind of mush this together.
Oh. That's gonna be fun.
Shoot.
No, I actually like this chapter. I think it's my favorite chapter.
Oh, this sucks.
Because we kind of like know what we're doing.
I want to show you. I've shown you one of these before, but now we're getting to the point where we're going to calculate part of what we saw in this journal article stuff here. Here we go. I like it. Association of leisure time with risks for cardiovascular disease. Neither. That part doesn't matter. Here we go. Now. Oh, you can't see this. Too bad. What happens? Stop it. Okay, there it is. You better stay there. You better stay there. You're trying to make me pay money. Stop it. You stay there. Stay. Look here. What's this? I want you to realize this is a journal article about a study they did between looking at the association between leisure time, leisure activities, how much time you devote to relaxing versus cardiovascular disease is one thing, right? Obviously, there should be some kind of a connection. Now, what I want to find, shoot. So that's kind of nice. There's confidence interval stuff right there. So what you're doing in class is exactly what's happening out in the real world. It's crazy. But let me see if they have the other thing I want. No, they don't have much else. Shoot. Too bad for Jeff. Rawr. Oh, here we go. Let's see if they have it here. I like this. The Jaha Journal. What is that? I have no idea. Journal of the American Heart Association. Woo! Yeah. All right, wait.
Goes back to the top, isn't it?
There we go. No. I don't want that. You've already looked at that. The next thing. Here we go. Perfect. All right. Can't see it. Darn it. There it is. Okay. So here they're talking about time of death versus the holidays. This might be something about the theory that people tend to die after they kind of hang on and then they afterwards. So this here, this dude right there is the probability that they saw what they saw, given that there was no difference. So they would say, like, we think there's a difference. We think that there's a difference between the percentage of deaths before a holiday and the percentage of deaths after. They believe there's a difference. So this would be the probability that the difference they saw was just because of random chance. Right, so this is the probability that what they saw. So for example, if we think that, so let's say I make a course that's supposed to raise people's SAT scores. You with me? So I do a study. I take a group of people in, and then I work with them for a few weeks, and then they go take the SAT test, right? And they do get a higher score on the test, right? That by itself is not good enough to show that I actually had an effect, because maybe just by random chance there are students who would have done well anyway. Because you understand that people that go for tutoring normally are good students, and good students normally have better grades. So when you look at a tutoring effect, you can't just say the GPA was higher, you have to say the GPA was significantly higher, statistically significantly higher. Right? So if I wanted to show an effect from that workshop I held, I have to show that the probability that what I saw was so low, the probability that what I saw was because of just random chance. You guys with me? If there's a random group of people I select, there's a chance I just happen to select people that would have done well anyway. But if the probability of that is so small, like that's only 1.3%, what's more likely is my course actually had an effect. So that's what we're going to get into. We're going to actually be able to calculate that p-value for ourselves in a test, in a testing somebody's claim. All right, how are we doing so far? So that's why I was desperately trying to find that, because I wanted to show you, this ain't just in this classroom. There's a freaking journal. Any journals you look at, you're going to see those little p-values somewhere in there, if they're good. Okay, so let me see if I can give you...
So if that would have been higher, it wouldn't be as...
Yeah, exactly. So this is where normally p less than 0.05 is acceptable. Then why does that sounds familiar? That 5%.
Right.
We've used that a few times. The cutoff for unusual was anything within where there's only 5% left outside. But it could be again. That 0.013 might not be good enough for somebody. Somebody's like, no, my 0.01 is my threshold. You're not small enough, screw you. And that's why journal articles give p-values so people can make up their own mind. Is that significant or not? And if you search for a p-value controversy, it's a huge controversy, and it's because people misuse p-values. So some people say, they suck, we shouldn't use them. And then I say, use them right, shut the hell up. Right? So they are useful, it's just that people try to use them in the wrong way. Does this mean for sure? Does this mean for sure that there's an effect? Because that p-value is small, right? But no, it doesn't mean for sure. There's a 1.3% chance, sort of, roughly, that I'm wrong, that there is no effect. It was just due to random chance. Hey, this is a lot to kind of throw at you, but we're going to do several of these examples. That's the idea of what we're about to do. So let's take a really simple example. Let's say, what's like the average gas price, would you say right now, for like the lowest octane? $2.59?
Yeah.
That's like the average gas price?
Yeah.
Somebody have a difference of... It's okay.
Right.
You look like you took it so personally. What's wrong with you? Where do you live? If you live in Carmel Valley, I feel bad for you.
Like 259.
Do 279, let's say, okay.
That's average?
Sounds better.
Right.
I don't pay attention anymore. It's like my car needs gas. I might as well not look at the freaking numbers. What point does that make? Alright. You guys good so far? That's amazing. No, we haven't done it. We think, so let's say that's the average gas price from the last time they checked. We think that it's actually higher now, let's say. We believe the mean gas price, California is definitely mean gas price, has increased. So can you write in mathish, probability-ish, the claim that's being made? So what does this look like in mathish? This is all English. What's it in mathish? We think that the mean gas price, so of course, what's that? Careful. This is a claim about the mean gas price, not the mean gas price of some sample. This is mu. Now, real quick, I want to make sure this makes sense. I'm never going to make a claim about a sample because I can see the sample. I'm going to make a claim about the population, and then I'm going to test that claim using a sample. Stop there for a second. So just by driving around, well, it looks like, I think it's higher than that. I think it's gotten higher than that. You with me? So our claim is that the mean is greater than what? 279. I like it. So what's the opposite statement of that?
It's less than.
Careful, it's not less than. It involves less than, but it's not good enough.
Or equal to?
Less than or equal to. Okay, let me see. I'm going to try something out with you guys. Which one of those could I actually show evidence for? Now, when you take a sample, so if I took a sample of people and I got an average age of 27.3, does that prove that the average age is 27.3 of everybody? No, of course not. But is that evidence that the average age is more than 20? Ah, okay. So we can never show evidence for an equality statement. Now this is going to build in later. I'm just trying to lay some groundwork right now. I can show evidence for this. But let me see if you guys understand. If we took a sample, let's say we took a sample now. So I can show evidence of a greater than or a less than. I can't show evidence of things that includes an equal to, because a sample is always going to be not equal to the real thing. So I can't show evidence of an equal to statement. But I can certainly show evidence that a sample is like way up above what I thought it was going to be and go, holy shit. Or, you don't have to do that. So let's say I take a sample now. We're exploring ideas right now. It's going to be there's going to be 5 steps that will always be the same steps. And I'm sort of getting the idea behind them right now. Let's say we take a sample of 41 gas stations. And we find X bar equal to 2, what you got, Jeff? 286. And S equal to, it doesn't really matter, just mix them up. Okay, Jeff, get off my back. All right. 31 cents. Sure. So again, nothing up here is really new yet. This little piece is a little bit new, but I mean, that's just, people make claims in real life all the time. Now, right now, why is that not good enough to just stop right now and go, hey, I've got evidence. It's larger. Leave me alone. I'm done. Yay. Yeah. It's just a sample. Shit. What could make this larger? I could have just happened to pick a bunch of more expensive gas stations, right? Maybe I live in an area that's a little more affluent, and the gas stations now they can charge us more, right? You guys understand what I'm saying? Okay, so maybe there's just even if I took a random sample, there could just be random fluctuations that would make that number larger than it really is. So the whole idea of this, what we're developing is, not only does that what I see have to be, in this case, greater, it's got to be greater than that enough. It's got to be far enough away from this. Because this is only a sample, right? If I took the whole population and I got an average of 280, I can stop. There it is. It's more than 279, but I'm using just a little sample. Poor little dude. Right? Okay. You can do it, Jeff. Where I want to go next. So, of course, what do we use in statistics to measure how far away things are?
Z-score?
Z-score. Use the standard deviation to see how far things are apart. Right? Okay, I like it. So the whole idea of a hypothesis test is sort of like this. Assuming that it actually is 279. We're going to do something and say, oh, look what we just did. It's really unlikely that what we just did means the mean is this. Let me say this again. This is a very strange little tricky part to say correctly. If the middle really is 279, then any sample I get should be, the average of a sample, any sample I take should be close to 279, right? That's the idea. So if I'm here, so like 286 might be here. Is that very far away from there? No. It looks like it's within one step away, right? From the scale of my picture. So that's what I mean. Not only do you have to be more, you have to be more enough. So we got to figure out what's that benchmark that I have to hit. So before this chapter, we knew the benchmark. How far away did we have to be to show that something was unusual?
95%.
2 standard deviations away, 95%, so 2 standard deviations away, right? But now it's going to depend on that level for the guy who thinks it should be 0.01 and that's not good enough, but there's another person who's like, no, 0.05 is a good benchmark for me, so that would be good enough. Do you guys see that? So the benchmark could change depending on, is it an insurance company I'm trying to prove something to? They're going to make that really hard to do. They're going to set the benchmark way up there. Or is it like a nuclear power plant? Again, I love that example. Where I'm going to set the benchmark here maybe. That little needle goes, I'm like, oh shit, let me go see what's going on. All right, let me stop there for a second. So again, all right. Can I get a Z-score from this right now? And actually, I mean, let me say this again. Let me be careful. Am I going to use T-scores or Z-scores for this problem? Yeah, 2 things you got to tell me now. Why?
Over 30.
Good. Over 30, so I know that the means are going to be normally distributed enough. And we only have S. I like it. But when you go to calculate a T-score, the formula you use is exactly the same thing as a Z-score formula. They're the same. That's why I call it a Z-score without even thinking.
Are we going to use the 95% or the area? Because it's not giving us...
I know it's not.
Okay.
I'm not quite there yet.
Okay.
But right now, I just want to see the numbers I made up. I'm curious where they end up.
Okay.
So if I do T-score, it's actually going to be the exact same formula. Let me be really specific with this formula now. Oh, yummy. So my data points are now sample means, of course, right? Sample mean. Minus the middle. Oh, I love the look of you. What are we assuming this to be? Who remembers? We're assuming it to be 279. So we're saying, assuming this is true, look what we just did. So if this is true, we should be there. If I'm way the hell out there, I'm going, well, assuming you're right, how the hell did I just get way the hell out there? So if our sample is far enough away, that's evidence that the picture maybe really looks like that. The mean actually is further up. Is it evidence that the mean is 286? No. Sample can never prove it's equal to something, but it can show that it's greater or less or different from something. Stay with me. Stay with me. Right now, we're investigating ideas. I desperately want you to realize we're going to have a much more organized thing here in a minute. It's going to have all these frickin' ideas in it, though, and I want to make sure the ideas make sense. That is the same formula as a z-score. It is. So I would do my data point minus the mean. We're assuming this to be the mean. Now notice what I have to do with this. Can I use this?
Yeah.
Hell no. That's the standard deviation for individual gas stations. So as always, I have to take the old one divided by the square root of n. So 31 cents divided by the square root of 41. This is where people get a little confused. When I divide by the square root of n, I'm not making a sample standard. I'm not doing that. I'm making a standard deviation of sample means. So no matter which standard deviation I know, that's for individuals. I have to convert it to one for groups of size, whatever. No matter what. So somebody help me out. What do you get there? 048. Yes, okay. All right. So 0.048. Let's see what we get here. Yeah, it's like 1.5.
458. 1.458.
That's pretty good. 1.46, roughly?
Yeah.
All right.
Wait.
You stop there for a second. What's up? People looking confused.
1.45, I think.
1.45?
Yeah.
1.45? 8. So 1.46. Okay. Now, tell me what you think about this. Do you think that is very far away?
No.
So remember, what was the benchmark before we even got to like chapter 7? It was always 2 standard deviations away. So by that benchmark, this is not unusual. The sample I picked, even though it had a higher mean, it wouldn't be unusual if the mean actually was this. I really want this to make sense. So in order to be evidence that the mean is more than this, I have to get a sample that would be unusual if this was the mean. That would be evidence that this ain't the mean. Now, so the one piece we're missing, I think somebody said it earlier, the one piece we're missing that we have to be given is what's my benchmark. Now, this is actually less than most of the benchmarks we would use. 1.645, or the associated t-score, but right, this is way smaller than most of those. So this would almost definitely be not enough evidence. All right, so let's do this. We're going to do this here. I have a little handout. I'm going to give it out to everybody. Don't read the whole thing over and freak out. We're going to go step by step through it. All right, we've already talked about most of these, the ideas behind them. I always want you to do these hypothesis tests using this. I'm going to say something now that I always forget to say. The book's homework says use the worksheet in the back of the book. Right? Screw that worksheet. You always do these steps. So they actually answer the same questions that the worksheet does, just in a better order and better, period. Yes?
So how would you say that, given what we found for T?
Yeah, let's say the benchmark was, it had to be 1.645.
Okay.
So did we make it far enough away?
No.
No. So we failed to show evidence that this is true.
Okay.
Yeah. All right. The wording is going to become very important, but I don't want to quite get to the details yet.
Start talking about the
Fail to reject.
reject. The
Exactly. So some of you guys had a little stats before. Sounds familiar. Some of you guys are like, well, I'm going to head show, okay? Right now. All right. There.
I'm gonna email it to her.
Oh, you are? I don't understand what this man has to do with
I've never had
sales.
With what?
Give the p-value and know how population is
Oh, cool. Oh,
All right. Well, hopefully.
Confidence intervals and stuff.
are you trying to tell me or ask? It's on the homework sheet.
That's Tuesday.
Oh, 170.